Alright, John, so sorry, that was my mistake. I completely forgot that when you take the square root of something, it becomes both positive and negative. So definitely something to keep in mind. We went back and we fixed this question. We got all 4 answers in all 4 quadrants. Now, let's take a look up here at the equation on the right and see if we can fix it. Let's not make the same mistake again. So let's just start over. We have sine squared theta plus 1 is equal to 0. I want to get that sine squared all by itself. So I'm going to add 1 to both sides. Sine squared theta is equal to 1. But I don't want sine squared theta, I want just sine theta. So I'm going to take the square root of both sides. That means sine theta. The square root of 1 is just 1. So this is positive and negative 1. Now, you can absolutely positively use your calculator to figure this out. All students take calculus. Because it's both positive and negative, I'm going to have an answer in all 4 quadrants, except for whenever your answer for sine or cosine, forget about tangent, because tangent, remember, is weird. It goes on for infinity and it doesn't follow a normal curve. Whenever your answer for sine or cosine is a 0, 1, or a negative 1, you don't really have to think about the quadrants and the reference angles and all that stuff. Whenever your answer is 0, 1, or negative 1, all of the answers that you could possibly need are going to be on the unit circle. I love this unit circle. It never ever goes away. It never dies. Isn't that fantastic? Okay, so remember how on the unit circle, this point is 1, 0. This is 0, 1. This is negative 1, 0, and the last one is 0, negative 1. Okay, so we're looking for where sine is positive and where sine is negative. So positive 1 and negative 1. Remember that the sine is the second number right there. It goes cosine, sine. So where is sine equal to positive 1? That's going to be all the way up here at 90 degrees. And where is sine equal to negative 1? All the way down here at 270 degrees. And you would have gotten that same stuff if you put it in your calculator. Second sine positive 1 gives you 90. Second sine negative 1 gives you 270. Oh, negative 90. See, that is why we don't like our calculator. See, because it's telling you that, alright, positive 1 is right here at a positive 90 degrees. But then they're saying negative 1 is down here at negative 90. Well, negative 90 is the same thing as 270 degrees, but it's just not fun. Don't write negative 90 as an answer. You want your answers between 0 and 360. That's why it's easier just to use the unit circle. Okay? Now, this equation, it's giving you things in terms of beta instead of theta. Now, they're both Greek letters. They both just stand for X, or they stand for Y. It doesn't matter, but they're just throwing it in there just to confuse you. It's not very nice. But if you want, you can just replace it with an X, or you can leave it the way it is. Anything that you want. But what I do notice about this, solve for beta in the interval between 0 and 2 pi. What does that tell me whenever it's between 0 and 2 pi? That means our answers have to be in terms of radians. Fantastic. Because we all love radians so much. Okay, so this is really the same thing as x squared minus x plus 3 is equal to 5. Now, whatever I'm going to do, whether I'm going to use the quadratic formula or whether I'm going to factor, whatever I do, I still have to set that whole thing equal to 0. So I'm going to subtract by 5 on both sides to set it equal to 0. minus 5 minus 5. Okay, so cosecant squared beta. I'm even just going to change it to a theta because it's just easier for me to write cosecant theta. Now 3 minus 5 gives me a negative 2. That whole thing is equal to 0. Now, can I find two numbers that add up to negative 1 and multiply to negative 2? Yes, I can. So I'm not going to have to use the quadratic formula. I'm going to do cosecant theta plus or minus something times cosecant theta plus or minus something is equal to 0. Adds up to negative 1, multiplies to 2, negative 2. So I'm going to do 2 and 1. Adds up to negative 1. So I'm going to do negative 2 and a positive 1. Negative 2 plus 1 gives me negative 1. Negative 2 times 1 gives me negative 2. Okay, so awesome. Now we're going between 0 and 2 pi. So we are going to have to change over to radians at some point, but not yet. I'm not going to worry about that just yet. So cosecant theta minus 2 is equal to 0. Add 2 to both sides. That gives me cosecant theta is equal to 2. I do not care what cosecant theta is equal to. I don't, because I don't have a button for that. It doesn't help me at all. But I do care that if cosecant theta is equal to 2, then its reciprocal, sine theta, must be equal to the reciprocal of this, 1/2. Awesome. That's easy. In fact, I know that 1/2 is one of the values on my magic table. Hopefully, you have a magic table sitting out in front of you that you can look at and figure out what this is. Alright, all students take calculus. That is a positive 1/2, so I'm going to look for where my answers are positive, here and here. So, this answer actually, sine theta is equal to 1/2. That's something that you should know right off the top of your head. Ms. Tompkins said that she wasn't going to let anybody graduate from Trig without knowing what sine of 1/2 is, and that's 30 degrees. Except for, remember, we're going to need all of our answer in terms of radians. I'm just going to list them all out first, then we can switch them over to radians after that. So that was theta, and then my second quadrant is 180 minus theta, or 180 minus 30, and that's 150. Okay, so those are the two answers that I got from here. Now let's go back up. I still have another side of the equation to deal with. Cosecant theta plus 1 is equal to 0. So I'm going to subtract 1 and get cosecant theta is equal to negative 1. I do not care what cosecant theta is equal to. I do care what sine theta is equal to. So sine theta is equal to the reciprocal of negative 1, which is just 1 over negative 1, which is just a negative 1. So the reciprocal is, it's the exact same thing. But remember, that answer is whenever you see a 0, a negative 1, or a positive 1, you don't have to do all students take calculus, you just have to do the reference angle formula. Remember that sine is the second number. Sine is the y value. So where am I going to go if my y value is negative 1? I'm going to start at my origin and I'm going to go down. So this is where sine is negative 1, and what's that degree? That's 270 degrees. Okay? Still need to get them in terms of radians though. So for every one of these I have to multiply by pi over 180. And remember, I'm not going to put the pi symbol into my calculator. I am only going to put the fraction in so that I can simplify it and reduce it just a little bit. Okay? So my real answer, theta is equal to 30 divided by 180, which I think is 1/6. Yep, that's 1/6. So this is pi over 6. 150 divided by 180. Enter, math, enter, enter. That's 5 pi over 6. And then the last one, 270 degrees. We actually know what that is in terms of radians. It's 3 pi over 2. But if you forgot, you could always just use your calculator. Alright, so those are my 3 answers. They're in terms of radians. They look beautiful. Fantastic. Okay. This is homework number 448. That's number 97. Okay? Awesome. So what I think I'm going to do is stop this video here and then see if I have enough time to go on to the last section, which has to do with identities. Yay, fantastic.